This video will go over the basics of soldering surface mount chips without expensive equipment. We're going to show how to solder a 603 resistor, a PLCC, a 44-pin QFP, and a 208-pin fine-pitch QFP. Some techniques for desoldering will also be shown. First, the bare essential tools: soldering wick or braid, tweezers, flux, .015 or .02 inch diameter solder, a 10x loop, and a soldering iron. Flux is the secret sauce to surface mount soldering. Flux removes oxides on metal that prevent solder from bonding to it, and it also helps to distribute heat. During typical through-hole soldering, all the flux you need is contained in the solder wire. When the solder wire touches a joint, the flux flows out and cleans the joint. However, in surface mount soldering, and this may seem like a mortal sin, oftentimes solder is melted on the iron and then carried over to the joint. During this time, the flux boils off and becomes useless, so additional flux is needed at the connection. A good rule of thumb is that extra flux is needed only if flux cord solder isn't being melted directly onto the joint. Here are a variety of different applicators that will be demonstrated: a bottle with a small needle, a flux pen, a brush, and paste flux. A stereo zoom microscope with 30x magnification is nice, but you can get by with decent lighting and a 10x loop to check your work, even on 0.5 mm pitch. A lighted magnifying glass on a boom is also helpful. As for a soldering iron and tip, a lot of this comes down to personal preference. I recommend getting a temperature-controlled soldering station with at least 50 watts and a 1/32 inch chisel or screwdriver-shaped tip. I don't recommend smaller tips because it's hard to hold any solder at the very end of the tip, and this is the key to some of the techniques shown in the video. First, we're going to solder a 603 resistor. 603 refers to the length and width of its shape, 60 thousandths by 30 thousandths of an inch. The resistive element is the colored side and should face up to help dissipate heat. First, flux the pads and then apply a small amount of solder to one side. This pre-fluxing may not be necessary if you apply the solder directly from the wire, but on smaller components, it's hard to avoid adding too much solder this way. Touching the pad with a tin tip may provide all the solder you need. Now hold the resistor with tweezers and reheat the tin pad while pressing down gently. The goal is to have the resistor line flat. Add more flux to the other side, rotate the board, and solder it by touching a lightly tin tip to the chip and pad. Here's an ideal joint. The solder should form a smooth fillet and look like it's clinging to the metal surfaces. Too much solder can make it hard to tell whether the solder is just sitting on top or is actually bonded with the metals. Next, a PLCC will be installed. As a side note, it's better to solder the larger chips first so that the other components don't get in the way. First, flux the pads. All flux is tacky and will help hold components in place, but paste flux in particular is slightly more effective in this regard. Nudge the component with tweezers until the pins line up on all four sides. Be aware that pin 1 is in the middle of a row on PLCCs, not a corner. Now place a small drop of solder on the end of the iron tip and touch one of the corner pins while holding the chip down. Next, we'll attack an opposite corner, but before doing that, be sure to recheck the alignment and adjust the chip if necessary by reheating the first pin. Once multiple pins are soldered, you'll likely have to remove the entire chip to make any adjustments. Desoldering just one surface mount pin is almost impossible. If I wasn't using paste flux, I'd probably add more flux now before soldering the rest of the pins. To solder one side, lay a piece of wire solder next to the pins and press it into each pin as shown. I'm using .02 inch solder here. You want to give the solder enough time to completely wick around to the back of the pin, but also apply as little heat as possible. For reference, my iron is at 610 degrees Fahrenheit. Here are some ideal finish joints. Note how the solder is filled in all the way underneath the pin and smoothly connects to all the surfaces. Next, we'll solder a 44-pin QFP. Again, flux the pads and align the chip with tweezers. To tack the corners, I put a small drop of solder on one side of a clean tip and then gently touch the toe of a pin. A small amount of solder should wick around the pin. Add more flux before soldering other pins. Here's that pin under magnification showing an ideal joint. You want to see a fillet or smooth ramp connecting the back of the pin to the pad. Here's the soldering process again under magnification. On the first pin, I touch higher up on the pin than necessary with the iron, but I lucked out and didn't create a bridge or short between the neighboring pins. The goal is to supply enough solder to form a fillet behind the lead while avoiding the creation of solder bridges. If you do end up with a bridge, oftentimes a bit of extra flux and a swipe with a clean iron tip will be enough to clear the connection. When this doesn't work, soak up the bridge with solder wick. A heavily tinned tip will aid in transferring heat to the wick. With some practice, a technique called drag soldering can enable you to solder much faster. Create a relatively large drop of solder on the tip and slowly drag it over the toes of the pins. Make sure to go slow enough to allow sufficient solder to wick around each pin. For this pitch, 0.8 mm, a loop is useful to ensure enough solder was applied to each pin. Finally, soldering a 208 pin QFP will be demonstrated. I mostly use the same techniques and tools for this pitch as with the previous one. First, flux the pads as usual and align the part. I have more luck with liquid flux than paste flux for this pitch. I'm using a small vacuum placement tool, although tweezers and fingers work too. Just be careful not to bend the leads. And if you do bend a lead, a dental pick or X-Acto knife is useful for straightening it again. Tack a corner by touching the toe of the pin with a small drop of solder. You may want to tack more than just 2 corners with this size of chip. Again, recheck alignment before tacking a second pin. Now add more flux. Proceed with the other pins similarly to the first pin. Again, the goal is to have solder form a small fillet at the back of the pin. I'm soldering this side only using good lighting and no magnification. Check results with the loupe to make sure each pin receives sufficient solder and that there are no small bridges between the pins. Another popular method is to flood the pins with solder and then wick away the excess. Surface tension will retain some solder under each pin no matter how long the wick is applied. This is why desoldering SMT devices is so difficult. I hate to argue against a technique that works, but I will offer these words of caution. For starters, it's very easy to overheat the board or components with solder wick. Also, oftentimes part of the wick will freeze while you're pulling on it, and this makes it very easy to accidentally tear off any pads or pins that froze to it. Lastly, as you can see from this magnified video, the wick can leave behind very little solder, so if you use this method, my advice is to be fast and gentle with the wick. Now for some quick advice on desoldering. For small chips like resistors, you can just add more solder and try to heat both sides of the component at once with an iron. Quickly alternating between each side will work too. Flux always helps. Special dual iron tweezers or hot air can also be used. Larger chips are generally removed with hot air and a wide assortment of nozzles in the industry. Another solution is a product called Chip Quick, which is essentially a low melting point solder that stays molten long enough to release all the pins at once. Watch how long this drop stays molten. To desolder a chip, first apply paste flux to the pins, then mix in Chip Quick solder so that it covers all the pins. Now continuously heat all the sides until the chip can be pushed off. You can clean the pads with solder wick, or, as the manufacturer recommends, cotton swabs and lots of flux. One final useful product to mention, smartboards. If you need a quick prototype and don't want to make your own board, these are great. They're also very easy to solder. The traces leading to the chips are actually small troughs pre-filled with solder. The chip leads fit into these to hold it in place. There's even a port in the middle of the chip for bottom side heat sinks. To install a chip, first flux the sides and then push solder from the edges towards the leads. No extra solder is needed. You will, however, need a tip that will fit into the troughs. I like to use one about half the pitch size of the component. Most of the time, I'd rather just design a board rather than wire up so many connections, but these are great in a pinch. They even have boards for BGAs. More detailed pictures, as well as a guide for hand soldering a QFN package, can be found at curiousinventor.com/SMT. Corrections are appreciated and can also be left at that address.